Citation metrics. Metrics have been devised as one means of measuring scholarly impact. A quote from the ARL website says this: "Quality and impact are two critical elements of the scholarly record. Research and scholarship is measured by both long-standing and newly developed techniques and tools." We've had a form of qualitative assessments for many, many years, and that is peer review. Peer review has served scholarship well, but some people think it's beginning to show its age. It can be slow, it can encourage conventionality, and it really fails to hold reviewers accountable. And the fact is, most papers, even those rejected, will end up being published somewhere, so peer review fails to limit the volume of research. More and more we are looking at quantitative assessment of a scholarly record. And it's defined this way again by ARL. Statistical tools have been used for many years to gather quantitative data on the impact of scientific and scholarly research. This set of methods and tools used is called bibliometrics. One form of bibliometrics is the analysis of citations. And in its simplest form, it is simply a matter of counting how many times an article gets cited, based on the premise that if it's an article of great worth, others will refer back to it. And that's as simple sometimes as doing a Google search. This is from a Google Scholar search, finding the article I was interested in, and just seeing how many times it's been cited. And here you can see this article has been cited 12 times. Another citation counting then led to more complicated ways, or actually more precise ways, of looking at the scholarly record. The H-index was introduced by Hirsch in 2005. So you can see most of this is still fairly recent activity. And the H-index doesn't look at that one single article, but it's applied to a body of work. It is a number that indicates the highest number of articles that have the highest number of citations. I don't know about all of you, but I'm not really much of a math person, so let me give you an example, and I think it makes it clear. I have a friend who has an H-index of 7. That means that she has at least 7 articles that have been cited at least 7 times. Now, she actually has hundreds of articles, but only 7 of these has the highest number of citations she's ever received, which is a 7. Hirsch suggests that after 20 years in research, an H of 20 is a sign of success, and 1 of 40 is indicative of outstanding scientists likely to be found at only major universities. An H of about 12 should be good enough to secure university tenure. I've taught many classes on this, and when I read this quote, most of the faculty laugh. Very few faculty have an H of 12. Well, there's some problems with the H-index. So what happened is it comes along and we have a lot of other variations of the H-index. And I'm just going to go over some of these. I really don't intend for you to memorize them. I just want you to be aware that they exist. I've taught workshops on this, yet every time I teach the workshop, I have to remind myself of the definitions of each one of these. The Zhang one is called the E-index. And really the whole purpose between this one was to differentiate between scientists with similar H indices, but with different citation patterns. There's an interesting phenomenon with the H-index. Let's say you produced a lot of articles in the 70s, and by the 1980s you had an H-index of 12. You would still have that H-index today, and maybe you have not continued to do research. So the contemporary H-index gives more weight to recent articles, and so that rewards academics who've maintained a record of scholarship instead of just a short burst of scholarship. Another interesting thing with the H-index is that it didn't compensate in any way for multiple authors. So the individual H-index is one of the ones that does this. It averages the number of authors in the articles that contribute to it in order to reduce the effects of co-authorship. The second one listed does the same thing actually, but it's the one that's used by Publish or Perish, one of the tools that is used for citation analysis. Again, a similar one here, a multi-authored H index. It's based on the resulting effective rank of the papers in undiluted citation counts. So again, this one is, what it does is to not reward those people who have co-authored or take something away from those authors who all of their articles are co-authored. Age-weighted, again, is similar to what we talked about before, what I mentioned before. It does, again, give more credit to recent articles and looks for the entire body of work and adjusts for each individual paper by age. So another very commonly used index is the G index. And it, again, was created as recently as 2006. And the definition of it is, given a set of articles ranked in decreasing order of the number of citations that they received, the G index is the largest unique number such that the top G articles received together at least G squared citations. Now they often show a chart, and I probably should have included it here, and it does seem to make this a bit clearer than that definition is. But let me again give you the example of the author I know who had the H index of 7. Her G index was 10. That means that the total cites for the top 10 articles equaled more than 10 times 10, 1001, which is 10 squared. So 10 times 10 cites. And another way we count citations is we judge the journal itself by how many citations. So the journal impact factor is the mean number of citations received in a particular year to articles published in the journal in the preceding 2 years. It's and I think the reason I have the question mark there, this is a metric of ISI, or Web of Science, and they don't explain the way they calculate this completely. This is what it appears to be, but it's a trade secret, and they don't tell you exactly how they do it. Even though this is what people believe. It is calculated by dividing the number of citations to articles published in that journal in the previous 2 years by the number of articles published in 2 years. So citation metrics receive a lot of criticism, and I'm going to go over some of them here. First of all, the G and the H indexes are based on a body of work. A new scholar won't have real numbers and won't have them for, meaningful numbers for many, many years. Lots of times influential work remains uncited. You know, sometimes we don't recognize genius for what it is. The metrics are narrow. They don't gather information usually outside the academy, so things like tweets and Facebook and blogs, all those kind of things are usually ignored. And it ignores the context and the reasons for citing. So think about that. A really bad theoretical offering may be highly cited just because it's inaccurate and it causes a negative reaction. So really bad papers often have very high citation counts. And authors can self-cite to raise the indices. Then this does happen. You know, I know of authors who, of course, they write in the similar on similar topics, so they often refer back to earlier articles of their own, and this raises their H index. Now, there is another index that removes self-citing as well. And the tools, we're going to mention some of them here in a minute, that are used to gather these numbers, they call them metric information services, are not consistent. And not only are they not consistent, they use different pools of data. So when we look at like Web of Science, for example, uses only the things that they index, and that's where they get their numbers. And date ranges and the way they interpret citations are different. Correctly attributing authorship can also cause reporting problems, and I have found this to be a big one. For example, I was looking for Stephen Bell, You remember him from Module 1, perhaps. ACRL leader and really well known, writes a good bit. But I had a really hard time weeding out, publish or perish for one wants you to use initials when you search it. So it's Bell, S period, I think it's J. And so I was getting it's a fairly common name, and I had a hard time figuring out which were his works and others. Now, simply if you know the discipline, you could go through and count some of them out, but you might as well count everything by hand if you're going to do that. Here's a little chart, and I should probably include the citation. A citation was taken and looked in these three different, these are the three top metric information tools, and this is the different numbers you got for each. Scopus had this article cited 130 times, 135, and gave it an H-index of 7. Web of Science 85, H-index 11. Google Scholar 279 and 10. So you can see what I'm saying about the problems here. I mentioned this earlier, the exact details of the journal impact factor are trade secret, and gaming is relatively easy. This is, again, there are editors who find ways to get more citations. They ask it's been heard that some editors ask their authors to cite only articles that they have already published, and that makes the journal impact factor go up. It's, again, sort of like self-citing the authors do. All disciplines and publication types do not give equal coverage. For example, books are seldom covered, and scholars in the humanities generally publish books, so they're at a disadvantage. Same as international publications. I've published in the United States and in other countries as well, and those ones from other countries don't get included. As we all know, numbers just don't tell the whole picture. There's a lot of danger in relying too heavily on a number for anything. What we have to look at these citation metrics as just one tool in our box of evaluating. So having said all that, you may think, why bother? It seems to be very problem-ridden, and why would we even do this? Well, a couple of reasons. For one thing, I kind of liken citation metrics to the e-book phenomena, especially the academic version of the e-book. E-books in academic libraries most often still don't download to a reader. They're still meant to be read on the screen. Every publisher does them differently. Some of them allow you to print a chapter, a PDF, some are PDFs, some are not. Everything about them is different, and but does that mean we don't use them? There's no consistency, but no, there's still value in them, so we still use them. So I think we have to look at citation metrics that way too. We also see that many schools are including this in their including this as a requirement in their promotion and tenure and reappointment procedures. They want faculty to use these. I think our role as librarians is that we inform faculty about them, we advocate, and then we teach them how to use them, and then we let them decide what is the most effective way of using them. I simply tell faculty, figure out what your H-index is, look at your citations, and if that's useful information for you, include it. If it's not, if it doesn't paint what you think is a true picture of your scholarship, then don't. Now, as I said, some places don't have that choice. They are being asked to. But I think it's our opportunity, our responsibility to teach and lead and assist here, and it's up to the faculty to decide which metric and when they use it. So this I thought was an interesting quote I want to read to you. But there's no doubt that among those who regulate funding of science, there's an increasingly bean counting mentality. So a single number that can be used to compare scientists and that fits neatly into an Excel column must be very attractive to the powers that be. This probably accounts for the very rapid uptake of the H-index as an accepted metric, and probably means that it is here to stay. And so I have to say that I agree with that. I think administrators who want to review files of faculty find it really easy just to look for a number. But we it's up to the faculty then to make their case and also point out other ways to evaluate their scholarship as well as those numbers. Altmetrics is kind of the new animal on the scene. And I'm going to read you a little quote from their website. You have the website there, and you have the authors who have written this manifesto. I believe it starts like this. In growing numbers, scholars are moving their everyday work to the web. Online reference managers Zotero and Mendeley each claim to store over 40 million articles, making them substantially larger than PubMed. As many as a third of the scholars are on Twitter, and a growing number tend scholarly blogs. These new forms reflect and transmit scholarly impact. That dog-eared but uncited article that used to live on a shelf now lives in Mendeley, Site You Like, or Zotero, where we can see and count it. That hallway conversation about a recent finding has moved to the blogs and social networks. Now we can listen in. The local genomics dataset has moved to an online repository. Now we can track it. This diverse group of activities forms a composite trace of impact far richer than any available before. We call the elements of this trace altmetrics. So the idea here is to filter and find other ways that scholarly articles and publications are being read and used, other than just citations. So I'm going to read a little bit more to you here. Altmetrics are in their early stages. Many questions are unanswered, but given the crisis facing existing filters and the rapid evolution of scholarly communication, the speed, richness, and breadth of altmetrics make them worth investing in. And there are a number of places and, again, metric citation tools that are starting to use altmetrics. Now, occasionally, altmetrics gets confused with article level metrics. And I just point that out to you, and you see we have an empty slide here, and that's because you have an article to read on article level metrics as one of your assignments, and it does differentiate for you the difference between altmetrics and article level metrics. We'll conclude this PowerPoint by just listing the tools for citation analysis. You'll have another source that will tell you a little bit about each one of these. Your assignment for this unit, this module, has to do with the use of these. So you'll want to make sure you look at each of these, the other resource on using Web of Science and Scopus. Web of Science and Scopus are both fee databases. Both of them are used by Kent. I will tell you that Web of Science has been down all weekend. I've been trying to get into it and get some screenshots to use for this presentation, and it hasn't been available. So hopefully by the time you're doing your assignment, it will be. Again, another downside to citation analysis is not everyone has access to these. And for many, many years, Kent had Web of Science but did not have Scopus, and then did a review trying to figure out which of the two to buy, and did end up buying both. Google Scholar is another one that's used a lot, and Publish or Perish is another free one. Google Scholar is very easy to use, of course, because everybody has access to it. Publish or Perish is also free, but you have to download it to your computer and use it. Now, that may sound simple, but sometimes in academia, our computers are locked down. I've taught workshops in using Publish or Perish to faculty who cannot download anything without the IT staff doing it for them. So even access to these tools can be problematic at times, and may be why Google Scholar is one of the more popular of them. So, the end.